Now, after talking about the data analysis part, now we move on to conclusion. Okay? Now, for conclusion, the rule of thumb is that you're actually trying to answer a question. Okay? The question is, can your data or is your data reliable enough for you to support or reject your hypothesis of the research question? Okay? So, uh, if your data is so unreliable so that you cannot draw a conclusion. In this case, in your conclusion part, you should provide the marker why your data is so unreliable for you to make a conclusion whether you should support or reject. Okay. Or it could be like maybe your data is reliable enough. Okay. Then you need to show the marker why, in this case, your data is reliable enough for you to support your hypothesis. Uh, yeah, so you just want to answer this question. You want to answer your hypothesis of the research question. Okay. This is the conclusion part. This is what you should be ultimately responding, okay, in this part of the lab report. Okay. Now, so we first start off with stating the relationship between IV and DV again, with your mathematical relationship of the best fit line, whether that's a straight line or a curve. Okay, so don't say something like, "Oh, as temperature increase, the rate increase," right? Or when pressure increase, volume decrease. Now, these are very low tier, okay, response. Okay, it would be better if you do mention about uh, whether it's a positive relationship or negative relationship. Okay. Except from that, you can talk about whether there's a linear relationship. Uh-huh. Uh, so there's sometimes, okay, it may not be just simply positive linear or negative linear. Okay. If somehow your graph, okay, is very good, that's proportional. Okay, that's actually very good. Okay, directly proportional or inversely proportional. These are something that uh, you can say as well. Okay, because in this case it has a deeper meaning. Just saying that one variable increase, another one increase, or one variable increase, another one decrease. Right? So use some of these terminology to explain your graph. Just bear in mind that a positive relationship doesn't mean that it's directly proportional. Okay? Or a negative relationship doesn't mean that it's inversely proportional. So just bear in mind. Okay? If it's a curved line, okay, then you can actually provide the mathematical relationship, whether there's exponential or logarithmic, power or polynomial, whatever. Okay, as long as you have the theoretical framework that supports that it's a curve, then do show me the relationship between them based on the equation of the best fit line. Okay. Uh, so after that, okay, then you can discuss any scientific meaning that is shown in your graph. Okay, so let's say there is a relationship between the solubility constant and the reciprocal of temperature. Okay, in this case, according to the Van Hoff equation, okay, then it shows us there is a huge scientific meaning is that the slope is equal to the delta H divided by R. That means the gas constant. Okay. Now that means in this case you can actually find the enthalpy change of that particular reaction, okay, including the uncertainty based on the max min line. In that case, you can calculate the enthalpy change together with its uncertainty. This gives the scientific meaning, so that's good. Okay. Or maybe, let's say in this case, right, the y-intercept actually does give scientific meaning as well, and so it would be good, okay, that you can find the entropy change together with its uncertainty. But of course, you do this simply because, let's say maybe because your research question, like your aim of the investigation is actually trying to find the delta H and the delta S of a particular reaction, okay, that involves the solubility constant. And so in this case, it is meaningful. Right? If if it's not meaningful, then might as well you don't do this part. So make sure everything that you're trying to discuss or analyze here, it should serve answering the research question, okay? And it serve the purpose of trying to find whether that is reliable or not. Okay. Now, I'll talk about this. Okay. For example, let's say you are calculating the enthalpy change of this reaction. Now, how does that relate to how reliable your result? How do you link up back to the reliability of the result on answering the research question? Okay. Then in this case, we call that comparing with literature. Okay. Now, this is for you to evaluate whether how well your data matches your theoretical framework. You don't actually have to repeat what you have mentioned in the design part. Okay, you bring out just simply you need to compare. Okay, for example, you are comparing a literature value of enthalpy change versus the experimental enthalpy change. Okay, then you can actually calculate the percentage error, and then if you have the percentage uncertainty as well, then you can actually compare the percentage error and the percentage uncertainty. Okay, just like what I mentioned here. Okay, now sometimes, okay, you might have several sources found online, okay, of different papers. Okay, so which value should you choose as a literature value? If that is the case, I think the best way is to compare the conditions of your own experiment versus that literature paper's condition, okay, and choose the one that's closest to you. Okay. Or on the other hand, let's say you are calculating the percentage error and you found there's error. Okay. The error may not necessarily 100% simply because you have done whatever methodological weaknesses. Okay. Sometimes it's just simply because the literature value that you are quoting do have a different condition. Okay. So that might encounter to the percentage error as well. But let's say if you're able to calculate the percentage error, then in this case, do compare with the percentage uncertainty to see if there are any percentage that is related to systematic error. Now, not all the time you're able to find a specific value to compare. Right? If you cannot find a specific value to compare or to calculate the percentage error, it's actually fine. You still need to compare anyway. You can compare a trend, okay, or you can just basically find anything to compare, and you must compare. Okay? The reason is because it's part of the rubric. Okay? Now, for example, let's say you're comparing a trend. Okay? Is your trend or is the slope or anything, is your mathematical equation is higher or less than expected? Like all these things, they do take into account on comparing. Like basically, you want to give an account to the marker, okay, to let him know that you actually do consider your own data versus your own theoretical framework, how well your data, your experimental data is representing your theoretical data, theoretical framework, okay, so that is a way to answer how reliable your data is. Now, except from talking about the accuracy part, okay, the percentage error part, okay, of course another part is the impact of uncertainty. Right, you can discuss error bar. This is why I say it's always best to consider the error bars here. The reason is because if you don't have error bar, then you cannot discuss the error bar. Okay, you can discuss whether there are overlapping error bars. Okay, you can discuss whether there are large or small error bars. Okay, now of course the smaller the error bar is better, right? The reason is because let's say if it's a graph, okay, let's say natural log k and 1 over t again. In this case, if the error bars are small, then you might be pretty more sure that it's a straight line. But if the error bar is so huge, okay, sometimes just because it's too huge, you are not very sure that whether it's a curved line or a straight line, because no matter which line, it can still pass through the error bar anyway. Okay, so in this case, no matter what, you can still discuss okay, how large or how small the error bars are and where they're overlappings. Right. R squared is one of the discussion where even though it's not much, right, but it do give us a perspective on how close the data plots are to the best fit line. Right. And yeah, so also when you are calculating the percentage uncertainty, just again make sure you can actually compare with the percentage error if you have, and then you can deduce out how much percentage is actually coming from systematic error.